We have with us today state climatologist Beth Hall and Sam Lashley with the Indianapolis National Weather Service. I don't believe I need to go into logistics too much. We are still very much in a relative stay-at-home phase, so the refreshments are in your refrigerator, the restrooms are at your place of residence, and thank you for attending today. I will, at this time, I believe, turn it over to Beth for any initial announcements. Beth, you're still muted.
Thank you. Thank you. So I'll just say a few words because the majority of this training session will be led by Sam Lashley with the National Weather Service. I guess just so I have a role to say something, I wanted to introduce Sam, but also point out that for those of you that may have participated in one of the CoCoRaHS informational webinars that occurred mid-April of this year, this is different. This is focusing now in on the specific training. This is an expectation with the CoCoRaHS community, just so that we have some confidence that everyone's on the same page with how they're doing the observations. But if you want to watch or didn't get to watch the informational webinar that took place, or you want to start spreading the word about how awesome CoCoRaHS is, I wanted to let folks know that a recording of that webinar is online. If you go to the CoCoRaHS.org page and then go to states and Indiana, you can see a link to that recording. So other than that, I just want to welcome everybody. From my screen, I see we're already up to 91 participants, so that's just amazing. Very appreciative of all of you taking your time to do this. And at this point, I will turn it over to Sam.
Great. Thanks, Beth. Can you guys hear me okay then? All right. Sounds good. Well, welcome everyone. What a great turnout. Thanks for taking time out of your afternoon on this beautiful day to join us for what we feel some very important and valuable CoCoRaHS training. So this will probably take about an hour, maybe a little more. I'll try and confine my comments as much as possible. But hopefully we'll get through all this, and then at the end you can post your questions in the chat and Hans will relay them and we can answer them the best we can. So I do want to give a shout out to CoCoRaHS here. We just had our 50 millionth observation recorded since the program began. So that's for the entire program across the entire North America. And that's just a pretty amazing feat for a citizen science program. So kind of patting ourselves on the back, and hopefully all of you will be part of the next 50 million and contribute to this program. So today we're going to get into that training. We have a little mascot there, Rainy the Raindrop, and Rainy is going to kind of help us present the information today. So with that, we'll get started. I do want to first off just mention that this training is precipitation measuring. It's about rain, snow, and hail. And this is not your typical spotter training. So some of you that maybe thought this was the usual National Weather Service spotter training, it's not. It's a different kind of training. So I hope you'll stick around, but if this isn't what you were expecting, we understand and you can drop off the call. Excuse me. But CoCoRaHS reports help save lives just like spotter reports. And it's through getting out better warnings for heavy rain, snow, and different kinds of precipitation. If you are looking for that spotter training, I do have a link there on the page that you can go to. Even after you take the CoCoRaHS training, if you want to learn about being a spotter training, just go to our Indianapolis YouTube page and you can view some videos on there. So with that out of the way, I want to give you just a real short introduction to CoCoRaHS. This is a little animation, and it's geared towards educators, but it's really presents a nice overview of the CoCoRaHS program. So just kind of ignore the part that talks about educators and teachers and just put yourself in that role, and we'll get started with it here. Maybe. All right, bear with me here. And it does not seem to be working here. in our WebEx. And of course, we're
Yes, Sam, maybe it's like you have a marker on. If you can go back to the pointer tool, the
yeah,
mouse.
that's what I was trying. Let's see here. Pointer options. There we go. Good job, Beth. Okay, let's get started here with this then.
CoCoRaHS. Calling all educators. Did you get any rain or snow yesterday? Have you stopped to think that it probably doesn't rain the same amount over one place to another? How wet did you get? Well, have we got a program for you? You're probably wondering what CoCoRaHS is. CoCoRaHS, the Community Collaborative Rain, Hail, and Snow Network, is made up of thousands of people, just like you, mapping and measuring rain and snow as it falls from the sky. Once they collect their measurement, it's only a matter of entering the amounts into our website, which shows a picture of how much rain fell across the nation. Each dot is a measurement, and the more dots on the map, the more meaningful it is to scientists. And I was just thinking, you know who can help add more measurements to our map? Schools. Why, you may ask? The cool thing about CoCoRaHS is that it is a great way for kids of all ages, K through 12 and beyond, to learn about where our water comes from and how the atmosphere works. Students will learn a ton by using and reading a real scientific instrument. Recording data and entering it online is great for students who are learning computer skills. For older students, there are opportunities to do more advanced measurements and also conduct their own data analysis. Participating in CoCoRaHS activities meets several of the state and national standards for science as well as math, geography, and more. And who uses the data? More like who doesn't use the data. Farmers need to know how much it rained in order to not overwater their crops. City water managers use CoCoRaHS data to both improve their water supply forecasts and to monitor and anticipate water demand. Ski areas, whitewater rafting companies, reservoirs for boating, and even professional sports teams use the information too. The National Weather Service uses precipitation data for something called ground truthing. This is where they compare their predictions and estimations to what actually happened. Using data from your school, weather forecasters can compare their radar and satellite images and hopefully in the future improve their predictions. And you know we would all love that. No school 2 weeks from Tuesday. The cost of a rain gauge is normally about $30. But as a school, the CoCoRaHS education coordinator may be able to help find a donation. He'll find a way. He'll also help you with instructions, lesson plans, and will even connect you with other volunteers who can assist in getting you started. So come and join, and soon you'll be like us. Cuckoo for CoCoRaHS.
Okay, so like I said, that's kind of geared towards educators, but a real good overview of CoCoRaHS and what your observations are going to be used for and the different organizations that will use your observations. And if there are any educators on and your school is interested, you can just drop me an email. I'll have my contact information at the end of the program, and we can look and see how we can get you some rain gauges and get you set up in this program. But it's really meant for people of all ages, from young to old. People, even if you have a job, we have a way where you can take observations before or after work. So what do you need to start to be a part of this program? Well, first, just a desire to make a difference and contribute to science. And, you know, we want dedicated people to be able to stick with this program. And we find that our observers are very passionate about CoCoRaHS. You need an open area for taking measurements. So hopefully you've got some place in mind where this might work and a gauge might be available. You will be required to purchase a standard 4-inch diameter rain gauge. We'll talk about that throughout the training, where you can find that. But we want every observer to be using the exact same equipment. So we're comparing apples to apples. So if you think you've got an automated rain gauge or an automated weather system and you're just going to use that, you can use that for an additional comparison. But to participate in this program, you really need that 4-inch rain gauge. We're going to talk about a snowboard and a measuring stick and what those encompass. Then you'll need internet access or a smartphone where you can download our app and use that. And then again, just a dedication to taking quality observations so that we have a very good scientific record with this data. We require our observers, for the most part, to observe between 5 a.m. and 10 a.m. It doesn't have to be that same time every day, though we prefer that. But for some of us that are meteorologists, we work rotating shifts. We can't always report at the same time every morning. So 7 a.m. is the preferred time. But if you report some mornings at 6 a.m., other mornings at 8, that's fine. There's an option to change that time each morning when you record. So there are some other options for outside of that 5-hour window, but we really prefer everyone do that. And then again, we're able to compare the same observations at different areas across the United States for roughly the same local time. CoCoRaHS.org is our website. We'll talk about this later in the program. This is where you're going to go for a lot of additional training information to enter your reports if you don't use the app, and also just to look at CoCoRaHS reports all around the country and compare your data to others across the country. So once you enter an observation in the morning, it becomes immediately viewable on our website. So here is just a national map. All these little colored dots are CoCoRaHS reports. So the grays are reports of no precipitation. We're going to talk about how important reporting zero precipitation is and how we use that data. Then we also have some blues, some greens, and some oranges, and those just designate different levels of precipitation, so you can see it just sort of in a big picture. But if we were to zoom in and click on Indiana and click on, let's say, LaPorte County, this is what the map is going to look like. So you kind of see the individual reports there. And then on the right-hand side, the reports are also put into a tabular sort of spreadsheet format that you can look at it very easily. You can even download this information. So I kind of hear the yard crew outside my window, so I apologize if there's a little bit of noise in the background here coming up. So here's just an example of how incredibly helpful CoCoRaHS reports are. This is a pretty historic event that happened a few years ago. You probably remember Hurricane Harvey and all the rain that fell across parts of Texas. And over a 6-day period in August, we had over 1,500 CoCoRaHS stations reporting precipitation, and that equaled over 7,000 daily observations. So that's a pretty incredible number. And of those stations, 15 reported over 40 inches of rain in 6 days. Now, can you imagine? Hopefully we'll never see that here in Indiana, but this is something that happens with a lot of tropical systems where you get just incredible amounts of rain, and we have to measure that. These observers also reported 168 what we call significant weather reports. We'll talk about that a little later as well, but these are supplemental reports in addition to your normal 24-hour report that you can submit this, and it actually comes right into the National Weather Service offices in your local area when you submit these. So we see your special reports immediately in our office. Here's another example of Hurricane Florence that was back in September of 2018. And this is using some of our newer maps with CoCoRaHS that kind of gives you a better idea of how much rain occurred. And you'll also see these for snowfall maps a little bit later as well. A neat thing about CoCoRaHS is while you see the precipitation there on the screen and the colored dots, you have the opportunity to enter notes with your observations. So here on the right-hand side, you can see a couple observations that were occurred. The top one, they reported 17.38 inches of precipitation, but their notes were very important in the observation that was not for the last 24 hours, but just the last 20 hours because the rain gauge was blown over. So these notes let us know that this was not a complete observation, and actually more rain might have fallen. Then in the bottom one, sort of a similar situation where they reported what they could, but it was not an actual amount because their rain gauge overflowed in the middle of the night. And again, hopefully we don't see that in Indiana, but these notes are very critical, and we're going to encourage you to put those notes into your reports when you can. So it's getting very loud outside my window, so I hope you're not hearing that too much. So your gauge and where to install, we're going to talk about next. So this is very important. Before you ever take your first observation, putting your gauge up, getting it installed correctly is going to be critical to getting some of those scientifically accurate reports. So this is what a 4-inch diameter rain gauge looks like. This is probably not something you have seen in the hardware store or maybe already have in your backyard, but this gauge is meant to hold up to 11 inches of rainfall. So we have the overflow or the catch tube there. That's the big 4-inch diameter cylinder. Then we have a funnel, and then we have an inner measuring tube that will be your primary means of measuring precipitation on most days. So we call this a precipitation gauge, not just a rain gauge, because it also is meant to measure and capture snowfall. And we're going to talk about what you do when you do capture this snowfall. So you kind of just see some different images here with snow on the left, and then a typical summer gauge in the middle or on the right-hand side. And again, we'll get into how you take these measurements and readings coming up shortly. So here's what your gauge looks like on your post. I've actually got one here kind of back to my left here, if you can see that in the background. But that's how it all fits together and how it sets on a post. So your entire gauge stays outside during the warm season, and you'll just go out every morning and take your measurement and empty it out. Then the inner tube and the funnel that you see there really has to be brought inside when temperatures are expected to go below freezing. That's because the plastic is thinner and it will crack when the water freezes on the inside. So unless you want to be spending $30 to $35 every season buying a new rain gauge, you want to bring those inside when it's cold outside. And that's going to allow these gauges to really last a long time. So the $30 to $35 up front might sound like it's quite a bit, but I still have a rain gauge that I bought back in 2008 when I started the CoCoRaHS program. It's old looking, it's kind of cloudy, the plastic's cloudy now, but that outer gauge will last, and the inner gauge will last a long time as well if you take care of it. So we'll talk about then the outer tube, how we use that again year round for rain and snow. So when you install your gauge, the location and accuracy and consistency are all important. We want this gauge to remain in the same place as long as possible. So if you have small trees or shrubs or bushes near it, it's probably not the best area, because as those grow bigger, you may have to move your gauge, and we want that gauge to stay in the same place. So we want an open area as far away from objects as possible. We're going to talk about here in the next slide, when you install that post, you'll see there in the picture, we want it mounted as close to the top of the post as possible. And if you're in doubt with where you're going to set your gauge, if you take a picture of the area and send it to us, we can maybe help guide you and where to locate it. But the next few slides, I think, will answer most of your questions. So here's just some examples of what your area might look like. The gauge on the left is probably what most of us here in Indiana are going to see. We've probably got a backyard, some trees, maybe a garden. And just putting it somewhere out in the open on a post that's maybe 3 or 4 feet high above the ground and easy to get to. We probably don't have too many pictures like the center one there, too many areas like that here in Indiana. But again, the point is just a nice open area in your yard. And then the gauge on the right is actually from the National Weather Service office in northern Indiana, and how we posted it on the post there. So kind of the rule of thumb is, if you have an obstacle nearby, ideally, whatever the height of that object is, whether it's a tree or a house, you want to be about twice that height laterally away from it. So look at that tree, double its size vertically, and then go that far away from it horizontally. Now that probably is going to be tough for a lot of people here in Indiana because we just don't have yards that big. So as a compromise, maybe whatever the height of that object is, just laterally that height will give you a pretty good observation. You want to be equidistant away from trees. If you can't make that perfect height, just kind of find it in the middle where you'll get a good open catch as the precipitation falls. But you definitely don't want it underneath a tree or overhanging branches or anything like that. Then when you install your gauge, we call it level and bevel. Just make sure that the gauge is even and square and level so it catches precipitation. And then the bevel part, you don't have to do this, but if you were to cut your post at an angle, that helps the precipitation kind of bounce away from the gauge rather than maybe a heavy rain and you'll get some extra rain that maybe bounces into the gauge. So not required, but if you're feeling inclined, you can do that. Now here are the two places we do not recommend you place your gauge. So having a little fun here, but the number one all-time worst place to put your gauge is to actually leave it in the box. We see this a lot. People will sign up for the program. They're all excited. They order their gauge, then they get it, and then they sort of procrastinate. I'll do it tomorrow. I'll put the gauge up tomorrow. I'll put the post in. And, after a certain amount of time, then you're kind of embarrassed and you're like, yeah, it's been a long time since I signed up. I'm not going to do it. And so it never gets installed and an observation never gets taken. So just please be motivated. We understand if it's a week or 2 weeks or even a month later, that's fine. Just when you get to it, go ahead and install it and get it up and those observations. Challenge yourself to get it out there. And then again, number two, the picture there kind of goes back to what we talked about, sighting your gauge. Make sure it's not near something that's going to give you artificial measurements. You're not going to get extra rain with water, maybe blowing off a nearby house or tree or something like that. So just make sure you have a good spot. So here's a couple realistic places that you don't want to put your gauge really close to the house. That'll give you, too many false measurements. And then the picture on the right underneath a tree, you're not going to get a good catch of precipitation under there. You're going to get false measurements. So with that, now we're going to move on to how to actually correctly and scientifically measure precipitation. I hope you like my baby picture there. I was pretty cute. Got to have some fun with this presentation, right? But this really is an easy program to do, and it's so easy. You can see in the bottom left there, even bears out in the wild can take CoCoRaHS observations. So we'll kind of move off from my humor there. And I'm going to show you another animated video here of how to take precipitation measurements. So you can stop listening to me for a minute and we'll play this video.
You found the perfect place to set up your rain gauge, left it outside to collect precipitation, and now it's time to take your daily measurement. Ideally, you want to take your measurement the same time every day, preferably at 7 a.m. Not all of us can be that consistent, so as long as you observe your gauge between 4:30 a.m. to 9:30 a.m., your data will be shared on the map and compared to others. If you check your gauge anytime outside of that window, your data are still accepted, but it won't be as useful to the people who depend on your morning 24-hour report. For example, meteorologists, farmers, and flood forecasters. Even if you enter your data later on, as long as your report reflects the time you observed your gauge, your data will be on the map. If your schedule doesn't allow for you to collect a measurement every day, there is a separate data entry form for entering multi-day reports. When we measure daily precipitation, we measure to the nearest hundredth of an inch. You may have noticed that your rain gauge has both an outer and inner cylinder. When water falls into the outer cylinder, it would be extremely difficult to measure the depth with accuracy. The inner tube acts as a magnifier. By squeezing the water into this smaller diameter inner tube, it stretches the measurement out in order to see the depth to the nearest hundredth of an inch. 1 inch in the outer cylinder will fill up your inner tube all the way to the top, where it says 1.00 inch. Looking closely at your inner tube, you will notice a small notch at the top. This is for overflow, or when it rains more than 1 inch. The water level may be over the 1 inch mark, where there are no marks to measure. You may have to give the cylinder a little shake to get the water line down to 1 inch or below, where you will be able to measure accurately. When you receive more than 1 inch of rain, you will need to pour your first inch out, and then use the funnel to pour the additional amount into your inner tube, writing it down each time until you have measured the entire amount. View our training animation called How to Measure Extreme Rainfall to learn more. To ensure an accurate measurement, please do not round. Also, be sure to put your decimal point in the correct spot, as it will make a huge difference. The most common measurement you will take will be 0.0. But don't be fooled. a measurement of zero is just as important as any other measurement. Zeros help us keep track of droughts and forecast water supplies. And sometimes the radar and satellites can fool meteorologists into thinking that rain is falling. Your zero could confirm that the rain evaporated before it landed on the ground. While it may not be as exciting as having rain in your gauge to read, zeros are valuable data. Sometimes you will find that your gauge has a little bit of moisture inside, but not enough to measure up to 1/100th of an inch. In this case, you would report T for trace. In fact, you may witness rain or snow, but not enough to measure. Here again, report a T, even if nothing landed in your gauge. When you have enough water in your inner cylinder to take a measurement, you may find that it looks like it has a small curve, or a thickness to it. This is called the meniscus. Always measure from the bottom of the meniscus to ensure an accurate measurement. Once you've got a measurement, record it in the report form in the field rain and melted snow to the nearest 100th inch that has fallen in the gauge during the past 24 hours. Then empty your gauge and set it back outside. For more information on how to record a measurement while it is raining or snowing, or more details on how to measure if you receive more than an inch of rain, please check out our video on how to measure extreme rainfall. And if you have any questions, feel free to contact us at info@CoCoRaHS.org.
All right, so some great tips there on how to measure. We're going to review those here really quickly. But all these animations I'm showing are available on the CoCoRaHS YouTube channel and on the CoCoRaHS website. So there's a lot more on there that we're not even showing. So I really recommend that you look at those. So just to go over what we talked about in the animation, that zero is very important. And I'll give you an example. We were working on a precipitation study where we're going back and looking at years and years of precipitation observations. So when we see a station that has reported what appears to be good observations, but there's several days of missing data, we don't know if that is just because an observation wasn't taken and precipitation did occur, or if they just didn't report their zeros. So by putting that zero in when it didn't precipitate, it lets us know you have a full record for your station, and we can trust your data, and we will actually probably use your data more than we would maybe when it's missing some observations and we're unsure. So really report that. It's very helpful, and we appreciate that. So a trace is just when you didn't quite get up to that 1/100th of an inch. So sprinkles, if you see a raindrop or you see just 1 or 2 snow flurries, that's a trace of precipitation. It's just not enough to actually measure. Some other times you might see some trace amounts in your rain gauge, maybe on those heavy dew mornings or when there's a dense fog bank that's moved over and that moisture condenses inside your gauge. So when that happens, that is not from precipitation. So we would want you to actually ignore that and report a zero. So some days it might be tough to tell, and you just kind of have to look back at the conditions, look at surrounding areas to see if precipitation fell or not. But a lot of just clear mornings, especially in the summertime when you get that heavy dew, you'll have maybe even 100th or 200ths of an inch of liquid in your gauge. So again, if it's not from precipitation, you just dump that out and you put a zero down and ignore that. So keep that in mind. So we never want you to round up. So if you have 4/100ths of an inch, we want you to report 0.04. So really keep that in mind. We see a lot of reports that, the same observer puts in just always a nice even number, and we don't want that. We want to know exactly what is in your gauge. Sometimes you will have that perfect, right on the number, 1/2 inch. That's fine. When it happens, you report it. But please get your decimal point in the right area. This is the number one error that we see with CoCoRaHS observers, especially if you're using the app where it's tough to actually enter in those numbers and you might fat finger it, so to speak. So that's very critical, and you'll probably get an email from CoCoRaHS, so don't be offended. If we're questioning your report, we're just trying to make sure, did you get 5 inches or did you just get a 1/2 inch? And in most cases, people are very understanding. They're like, oh, thanks for catching that. It was just a 1/2 inch, and we can make that correction very easily. But just really focus on getting that decimal decimal point in the right area. So again, you saw in the video, when you get an inch, it's going to be right there at the top. But you can see there's a little bit of room between the 1 inch and the very top of the gauge. So there's a little notch right in that gauge. I'm going to see if I can show that to you here with my gauge. I'll see if I can put this up to the camera. And maybe you can see it right there. You see that little notch that is right there. So when this gauge fills up with water, it'll actually overflow out of that notch into the bigger tube. So once that happens, we start collecting the additional rainfall in that bigger tube, and you'll end up with something that looks like this. So you can kind of just eyeball this. You know you have an inch in that inner cylinder. And then as just a rough estimate, you can look at those ticks on the smaller one, and that equals about an inch for each tenth there that you see in the outer gauge. So you would think, okay, I've got an inch in the inner tube, then I have another 1, 2 to maybe 3/4 of an inch. So it'll give you just a generalized eyeball of how much is in there, but we want you to actually measure that to know exactly how much is in there. So to do that, like the video showed, you're going to read that first inch, kind of shake your tube, and I really recommend when you start this process is to have some kind of a container or a bucket underneath you, because our motto at CoCoRaHS is every drop counts. So we don't want you to lose this critical precipitation data. That's going to give you a bad measurement. So until you get the hang of this, have something underneath as you do this. So you take that first reading, you have an inch, you pour that out, and then as you can see there in the picture, you put your funnel on top, and you pour the rest of the water into that inner tube. This is where it gets tricky, because that inner tube will fill up very quickly. And you got to remember, when you stop pouring water, there's still water inside that funnel that will go down into the tube. So that, in some cases, if you pour too fast, will actually overflow and you will lose water. And you can't get that precipitation back once you lose it. So keep that in mind, and then you just do this and keep track of each time you do that and add up your measurements just like you saw in the video. And that's how you measure when you get more than an inch of precipitation. The meniscus we talked about, here's what it looks like. So this is just the surface tension kind of pulls that moisture up on the outer part of the tube. So you want to read that bottom part of the meniscus to get an accurate reading. And sometimes if you just click the tube with your finger, kind of like they do with a syringe at the doctor's office, sometimes that'll level that out and make it easier to read. So that's it for measuring rainfall, really. Now we're going to move on to how to measure snow. This it gets a little bit more in-depth and technical. So in the wintertime, it may take a couple extra minutes to measure snowfall. So yes, that's a measurement of 54 inches there. Again, hopefully you don't see that too much in Indiana. But when it happens, we're going to have your report to learn more about it. We begin with what's called a snowboard. So this can be a piece of plywood, something roughly 16 inches by 16 inches, give or take a little bit. But we want it to be something relatively heavy that's not going to blow around, so plywood works great. And it really needs to be a bright white. So you'll want to paint this board so it reflects energy and doesn't absorb heat. Also, this is very important, mark your snowboard location with a flag or a stake out in your backyard. As I learned the first time I took my first snowfall observation when I got about 6 inches of snow, I couldn't find my snowboard. So I knew where it was in my backyard until we got the 6 inches of snow, and suddenly I can't find that 16 by 16 inch piece of board. So if you don't want to look like a fool to your neighbors and your family looking out the window at you, have a little stake there so you can walk right to your board. So I'm going to show you another animation here that distinguishes between snowfall and snow depth, but it's a little confusing, so I want to bring it up here first as an introduction. So snowfall is what's going to accumulate on your snowboard in that 24 hours between your observations. So between 7 a.m. and 7 a.m. the next day, you go out in the morning, you're going to take several measurements on your board and average them to get an average snow depth to the nearest tenth of an inch. We don't want you going out during a snowstorm every hour, taking a measurement, and then adding those up. That will give you a false inflated number. Scientific measurements actually allow snow to compact because you get a lot of pockets of air in there as it accumulates, and you'll get a false reading. So you can go out when a snow event ends and take a measurement, but just don't clean that snowboard off until the next morning at your normal observing time. Take your measurement there, and that's going to be the number that you report to us. Snow depth then is what accumulates just on the ground in general in your yard over time. So this measurement you would take every morning with your snowfall measurement, but this one you're going to go around your yard and take several measurements, maybe 6, 7, 8, 9, or 10 of varying degrees where you have natural variations in the snow, and then you take an average of that and you report that to the nearest half inch. So the next couple of videos are going to explain that a little bit more in depth, but I just wanted to bring it up here so you got an idea of what the difference is between them. So let's watch here on how to measure snowfall. And again, that's snow that has fallen in the last 24 hours.
Snowfall is the accumulation of snow and ice in the last 24 hours, prior to melting or settling. With this caveat, your normal observation time may not be ideal for measuring accumulation. Ideally, the best time to measure is right after the snow has fallen. For example, if a storm came through at 10 a.m. and lasted until 2 p.m., you would want to measure accumulation right after 2 p.m., before melting or settling occurred. This is not always feasible for volunteers who are working during the day or may not be home when the snow stops falling. This is okay too. If you are not at home when the snow stops falling, you can still measure the snowfall at your normal observation time. If you know what time the snow stopped falling, or if snow was falling while you are taking your measurement, please add this to your observation comments when entering the data. To measure accumulation, first find your snow measurement board, which should be easy since you remembered to mark its location with a flag or reflector. Slide your snow stick or ruler straight down into the snow towards your snow measurement board. Try to get down close to where the ruler meets the snow, because if you are looking at an angle, you will get an inaccurate measurement. Write down the measurement to the nearest tenth of an inch. You can also take multiple measurements in representative locations and calculate an average measurement. Before you clear your snow measurement board, you will want to take your measurement for the liquid water equivalent of snow, explained in the next section. When you are done, you can clear your snow measurement board and place it on top of the snow, so it is ready for the next time you measure. Report your measurement in the field, accumulation of new snow in inches to the nearest tenth.
Okay, so I just want to clarify a point there. When I said, we want you to take your measurement the next day, a lot of times you're going to get snow that falls and then it's going to end for a couple hours and then it's going to snow more. So if you know the snow event is done and you're not going to get any more additional snow prior to the next morning, you can go out and take that snowfall reading at that point when the snow ends. But if there's any chance that additional snow is going to fall, what we don't want you doing is taking multiple measurements and adding those together to get a big number. So hopefully that makes a little bit of sense. That is one of the most confusing parts to taking snowfall measurements. There was a case a couple of years ago, I believe it was in Erie, Ohio, or Erie, Pennsylvania, where a snowfall observer actually took measurements every hour and just added them together. And they actually threw out what would have been a state record because that was an inflated amount of snow. So just go back and review the training. And if you have any questions on this, you can send me an email and we can talk it over more. But that is probably the most confusing and difficult part of measuring snowfall. So here's what it's going to look like when you go out to take that observation early in the morning. And there we have our snowboard flag. You can see how it's kind of difficult to see. And you want to get down very low, just like they showed in the video, and use your ruler. And you're going to put that in a couple different spots across the snowboard, see what the readings are to the nearest tenth of an inch, and then take an average of that, and that's what you're going to report. Once you do that, you pick that snowboard off, clean it off, and set it back on top of the snowpack, so then it's ready to accumulate more snow and it doesn't get buried down below the current snowpack. The reason we ask that you get down and take that measurement, is because you might get a false reading. When you're standing up and you look at that angle, you're probably going to be off by a couple tenths of an inch. The other thing to keep in mind is your typical ruler in your house is in eighths of an inch, but we're asking you to report in tenths of an inch. So you may have to do some rounding and estimating if you have a regular ruler, or if you want to buy what's called an actual snow ruler. These are made and printed to the nearest tenth of an inch, but these can get a little bit pricey, so you may not want to purchase those and just use your regular yardstick or ruler you have in your home. So with that, we'll move on to how to take snow depth measurements here.
Now it's time to measure the total depth of snow, including old snow and ice, as well as new that is on the ground at observation time. To do this, stick your snow stick or ruler through all of the layers of snow and ice onto the ground and measure to the nearest ½ inch. Because snow rarely falls uniformly on the ground, take several measurements and average them to find your total depth measurement. Don't measure artificial accumulation spots, such as plowed piles, large drifts, or shoveled snow. If parts of the ground are bare, you should use them as measurements to put into your average. For example, let's say half of the ground is bare, and the other half, after taking multiple measurements, averages out to 2 inches. Your total depth measurement would average out to 1 inch. If more than half of the ground is bare, report T for trace of snow. Since this measurement is taken during your normal time of observation, typically around 7 a.m., if possible, please report your total depth of snow every day that there is snow on the ground, even if you didn't receive any new snow. Report your measurement in the field depth of total snow and ice, new and old, to the nearest ½ inch.
Okay, so again, with snow depth, you're taking, over a larger area in your yard. We're trying to get an idea how much snow is left on the ground or how much is now there after several snowfall events. So snow depth, you're going to take that measurement every morning, regardless of if you had precipitation or not. So let's say you went 24 hours, you had no snow, no rain. We still want you to go out and measure what the snow depth is and report that with your zeros. So that will actually help us when all that snow goes to melt. We can actually try and forecast moisture and water is actually going to run off and go into the rivers and maybe lead to flooding. So it's very important that we know how much snow is on the ground across the area. So again, as was showed in the video, you're going to stick that ruler down. Now here's a little secret to taking snow depth measurement. You can get some false readings with snow depths. We want you to make sure, does that make sense? I've only had 2 inches of snow over the last 2 or 3 days, but I'm getting 4 inches of snow depth. What's going on here? Well, you can get an inflated reading because that snow will sit on top of the grass. When you stick that ruler down, depending on how tall your grass is from the fall when the last time you mowed it, you might have 2 or 3 inches of grass thickness between the ground and where the snow starts, and that will inflate your snow depth. So the little trick here is when you put your ruler down, hold on to it very lightly, and when you stick that ruler down, you will actually feel the top of the grass, and it'll feel a little spongy. So when you feel that sponginess start, that is the top of the grass, and that is most likely where your snow is going to start. And you read that measurement then from there rather than going all the way down to the hard ground. Another thing you can do if you're still not sure or question it is take your glove and just kind of reach down like a claw and slowly pull that snow away down to the grass. And then stick your ruler down on the edge of the snow, and you can read and see where the bottom of the snow is and read that to the top of the snow, and then round that to the nearest ½ inch. So that's a couple tricks, and that should generally get you in the ballpark and make sense with what you think you should see on the ground for snow depth. And like the video showed, here's a picture of what you might see, as snow starts to melt. So what do you report for snow depth here? You got some areas of 2.5 inches, some areas of an inch, inch and a half, and some zeros. So again, you're taking multiple readings around the yard, and then you're going to average all those together. So here, if half the ground is roughly 2 inches and half the ground is bare or zero, what's your total snow depth? It's going to be 1 inch, that average there. So moving on from that, now the next and final section we're going to cover on measuring is what we call the snow water equivalent. This is very critical, especially for a hydrologist. We want to know how much liquid is in that snow. You've probably experienced those very heavy, wet snows where it's difficult to shovel. We call those concrete makers. And then you have the lake effect snows that are very fluffy and light and just blow off. That weight, so to speak, comes from the amount of moisture or liquid that's in that snow. So we want to know for each snow event what that content is. So we're going to talk about here about what to do. So again, just a reminder, in the wintertime, you want to make sure that that inner cylinder and that funnel has already been removed from your gauge. These should be sitting inside or it's nice and warm. And your outer cylinder is what stays out year round on your post. So here's what it might look like after a snow event. You go out to read your gauge and you see there's actually several inches of snow piled up on top of your gauge. What do you do in this situation? Well, hopefully everyone has in their kitchen their handy dandy snow swatter. You probably didn't know you had one of these. And if you don't, you can actually purchase these online and get one of these from the CoCoRaHS vendors. But what we want to do is just try and randomly see how much of the snow falls in the gauge. So what you're going to do is take a spatula or a fly swatter, take it out to your gauge, and you're just going to kind of come down on the top of that snow that's sitting on your gauge, and you just go straight down to the gauge itself, and then you horizontally move the snow away. So basically what falls in the gauge falls in the gauge, and what falls it doesn't. You're trying to be a little bit of a mother nature here and just randomly collect some of that snow that might have fallen in or out of the gauge. So this is the best thing we can do, but that's what we recommend. Sometimes I might take my glove and actually go down on the top and scrape it, but hopefully you've got some kind of tool like this that you can use. So another little bit of a tip is, you've done this, you're going to take this gauge inside. We're going to show you how to melt the snow down and turn it into liquid. And then you're going to have to bring that gauge back out and set it up outside. I'm a little bit lazy, so I actually purchased a second CoCoRaHS gauge, and I just take the dry tube outside, take this off, put the dry one on, and I go inside and I'm done in one trip. So if that's something that interests you, saves you a couple trips going in and out, I recommend that. If not, that's fine. You're just going to take this in, melt it, and then bring it back out. So once you get inside with this snow, you're going to take that inner cylinder and you're going to fill it up with some warm tap water. The critical part here is remember how much water you put on that inner tube. I try and fill it up as close to a ½ inch as possible because we're going to do a little bit of math here, and it's good that you always know how much you fill that up. So in this case, you hold it at your eye level, you see how much water is in there, and then you pour that into your container holding your snow, and you might have to swish it around, but that snow should melt pretty quick. And once you have all the snow melted, then we're going to measure how much liquid is in that container. Now keep in mind, if you have a big snow event, usually 6, 7, 8 inches of snow, it's going to take probably at least an inch of water that you're going to have to add to get all that snow to melt. Now the other option is you can let this gauge just sit there and let the snow melt naturally, but that's going to take a couple hours, and this is a way to get it done in a very short period of time. So then you put your funnel on top, you pour that moisture in there just like you would when we had more than an inch of rain. Remember, every drop counts, so be very careful as you're doing this. And then again, you bring it up to eye level and you take that reading, and remember at the bottom of the meniscus if you have that meniscus. So once you do this, let's say we read 0.79 inches, okay? And we had added a ½ inch of water. So we subtract that ½ inch that we added, and our final reading now is 0.29 inches of liquid. So that's how much liquid was in that snowpack. So you've probably heard the term, if this snow was all rain, or if this rain was all snow, how much would it be? This is kind of where that comes from. The old rule of thumb was, 1 inch of rain equals 10 inches of snow. That generally is not true. That's just sort of an average. Those heavy wet snows, it's a lot, there's a lot more moisture in there. And those lake effect snow, there's a lot less moisture in there. So those ratios will vary from time to time. So if you're always reporting a 10-to-1 ratio, you're just going out and measuring the snow and then figuring out what that, moving that decimal point over 1 and reporting it, that is not what we want to see. You should, in all honesty, rarely have that perfect 10-to-1 ratio. What do you do if the wind's blowing and you can't get an accurate measurement? Well, just do the best you can. We know there's going to be times, that wind's howling at 20, 30 miles an hour. You're not going to get a good catch in those gauges, and you're not going to have a lot of snow on your snowboard. When this happened, just put in your notes that there was a lot of wind, just like you saw for those hurricane examples, and just explain why you think maybe your observation is not accurate. Do the best you can. We know it's not always going to be perfect, and we know you're not experts at this. And just make note of it. That's the most important thing I can say. So that's really it when it comes to measuring precipitation. So I know we threw a lot at you there very quickly. The final stage here, we're just going to talk about the CoCoRaHS website and how to report. And then we'll hopefully have some time to take any questions on anything that wasn't clear here coming up. So this is the CoCoRaHS website. If you haven't been there and signed up, this is where you're going to sign up. Again, this is where you're going to take your observations and do all of your work through this program. When you do sign up, you're going to be sent a welcome email. You're going to get a username and an initial password that you can go in and change. But when you go to the website, you just click on up there where it says My Data Entry. It'll ask you for that username and password. And if you click that Save Login button, then on that computer, you will never have to enter that information again. It will just recognize you automatically when you show up on their website. So that's a good little shortcut we recommend you do as well. So then at the top there, it says My Data. You'll click on that once you're in, or over on the left-hand side under Enter My New Reports, Daily Precipitation. That will set you up on this screen, and this is where you're going to enter all your information. So it will default to 7 a.m. and the current date. And there we go. And so again, if maybe it's 9 a.m. when you take that observation, maybe you slept in or you worked the third shift and you came home, you would go in and just change that to 9 a.m. and you're fine. Then you're going to enter what's in your rain gauge, whether this was the actual rainfall or this is what you melted down if you had a snow event. You're going to put it right under that time where it says rain and melted snow in the nearest 100th of an inch that has fallen in the gauge in the past 24 hours. We're not going to talk in this training about the melted core values. You can get more training on this online. So here under new snowfall and total new snow and ice on the ground where it says melted values from cores, those are a little bit more advanced topics, and we found that it causes a little bit confusion. So if you want to learn more about that, take the training online, send me an email and I can talk to you more about that. But you're not going to have to worry about those right now. So those just stay as NA or not available, not reported. Then here we have record the snowfall accumulation. So this is what's going to be on your snowboard. This is your 24-hour amount that goes there under new snowfall. And again, that's going to be to the nearest 1/10 of an inch. And then down below here is where your snow depth to the nearest 1/2 inch will go. And you can put that right in there. Then you can see there's some other places for additional information. If you happen to track when the precipitation began or ended, you can put it right in there. If you notice any flooding, there's a drop-down menu there. You can select the degree of flooding. That is all completely optional. And then when you're done with that, you can enter any notes. And that's where you would put it in that section right there. So once you're done with all that, you just hit Submit Data, and your report is automatically entered into the database. It will go on the map. It usually takes a couple minutes maybe for your report to show up on the map, so give it time to process and show up. If you have a smartphone and you want to use an app instead of the website, the app is available for both the Android and iPhone. This is kind of what it looks like. a very simplified version of that web page where you would enter your data. And again, just more options. And then you just hit submit. You can take that right out to the gauge with you if you want and do it right from there. So if you do want to see your report on the website, you go to the Indiana page and just click on the county where you're taking your observation, and boom, lo and behold, there's your report. Should show up on a map. Again, this is another great way to double check your report. Did I get the decimal in the right place? Am I close to my surrounding reports? But don't feel like you need to change your report. We don't want you to change your report. There will be differences. You can see a pretty significant difference there between this report and the one just to the north. So you will see differences. And now maybe if you have 5 inches and they have 1/10 of an inch, then we might have a problem. But just a self-check for you there. So some other useful reports here as we start to wind up. We're getting close to our hour. Hail reports, you can report hail through the system. Again, there's more training on that. We're not going to cover that for the sake of time. But you can report hail, and maybe you get a quick heavy downpour and you get 3 inches of rain in an hour. You can file a significant weather report from the website where you can tell the National Weather Service that you just got that rainfall amounts. Now, you're still going to report like you normally would at your 7 a.m. time. But again, when you submit this report, it will go right away immediately into National Weather Service offices and alert them that something significant is going on. So please take advantage of that. Some other things there that you can do. We're going to talk about the multi-day report real quick. Let's say you go on vacation. We allow that. We don't expect you to take these observations every day. So let's say you go away for a week. Well, when you come back, instead of entering a report in the single day observations, we want you to enter that under multi-day here. You put the first day that this period started, then the date the rain gauge was emptied, and just you put in there how much was in that gauge while you were away. So this keeps those multi-day reports separate from our single day reports so we don't get them confused. So a couple things to remember here. For morning dew, no, we don't want you to report that. The condensation from fog, we don't want you to report that unless there was actual drizzle or rain falling within the fog. So it's important that you recognize that difference between dew and precipitation. And again, it can be difficult on some mornings. I've had to go look on the Weather Service site some days where maybe we had a 20% chance of a shower and we didn't get it, but we got dew. I had to go figure out which it was. So sometimes it can be difficult. Please report those reports on days when precipitation did not occur. Those zeros are very important and help us distinguish for research purposes especially. Yes, we will possibly contact you for your report, so please don't be offended. We're just making sure the data is right. We're not going to be upset. We know mistakes happen. I've made mistakes before. I've caught myself on them. So we just want to make sure we have the most scientific, sound data as possible. So that's most of the training. How do you get started? Sign up on the CoCoRaHS website if you haven't already. In the top left-hand side, it says Join CoCoRaHS. You'll fill out your name, address, contact information, submit it, and then you'll generally get a welcome letter within a couple days, if not sooner. On the CoCoRaHS website, on the right-hand side, there's a couple of vendors that sell these 4-inch diameter rain gauges. Check them out. I think one of them gives a discount for CoCoRaHS observers, so you're in that $30 to $35 range. And then once you get that, get it set up, start taking and reporting your measurements and have fun and enjoy the program. I mentioned the additional training. There's where you get it on the left-hand side. There's just the links outright. Those animated videos and more of them are on the YouTube website. They're really fun to watch. They're well done, and they really explain things in great detail. So check those out if you want to see some additional ways to measure precipitation. And then here's some other useful websites I've put together so you can always come back to this training, go right to this slide, and get that. The CoCoRaHS main page there, the PowerPoint training, again, on those links. There are some lesson plans for those of you that are teachers. There's even some 4-H plans on there. CoCoRaHS in Indiana has been incorporated into the 4-H weather program, so you can learn a lot of information about that and maybe how to do some more advanced 4-H weather projects with CoCoRaHS. And then, of course, the National Weather Service site on there. And sorry, Beth, I've got to add the new iClimate site on there. You can see down there in the left-hand side for the state climatologist office. Just Google Indiana Climate or state climatologist, and there's some really great new tools on their website as well. So with that, that's Nolan Duskin there. He's the gentleman from Colorado that started this program back in the 1990s after a big flood in Fort Collins. So we really owe everything to Nolan. And with that, I think I'm right at an hour, which is really good. And we'll open it up to questions out there if Hans has any for me.
We certainly do have questions. You're more than welcome to enter additional questions into the chat or Q&A box. But I think we'll start out with a pretty common question is, will this recording be shared? Will the slides be shared? I'm happy to share the recording. Sam, would you be willing to share the slides?
Absolutely. We can find a common place for this and put that out there.
Okay, great. One question early on is, let's say 5 to 10 a.m. is going to routinely be an issue for a reporter. Should they still go ahead and get a gauge and report, or is this not the right program for them?
No, they can absolutely still go ahead and get a gauge and report. We'll have to do some special circumstances. They just have to know their report will not show up on the map every day, because those are for specifically those reports between those time frames, so that we're if we have a rainfall event that occurs between, let's say, noon and 4 p.m., if we put that on the map, the person was reporting at 6 p.m., it would throw everything out of whack. So we still collect the data. It still goes in the database. It's still very useful. It just won't show up with the rest of those observations. So that is fine, and we're happy to take that report as long as you're aware that's what's going to happen. And you can also always then submit those significant weather reports as well as an observer. Great question.
Excellent. Yes. Another question concerned measuring snowfall. There were two things in there. Wait until the snow stops and measure, and then measure snow at that 7 a.m. time period, same as we would for rain measurements. Which or both is ideal?
Yeah, again, that's that confusing and tricky part. And so again, if the snow ends and you are certain we're not going to see any more snow between when it ends and your 7 a.m. observation, you can go out and take your observation at that time and record that amount. But if there's any chance you're going to get additional snowfall, then you really should wait and not measure until your 7 a.m. because we don't want to overinflate multiple measurements, which is what you would get. So that's the best advice that we can give you. In most cases, you're just safe to wait until 7 a.m. If you want to go out and just measure that just to get an idea of how much is out there and report that when it does end, you can do that. Just don't clear that snowboard until 7 a.m. the next morning as well.
Okay. We've got one participant who plans on moving in the future, perhaps multiple times, and may end up on the 3rd floor of a condo. Should they participate? Yeah, that's pretty much the question.
Yeah. Well, the beauty of this program is, if you've got a place to put a gauge and you sign up, you can take observations. Then let's say you're going to move in 3 months. Okay, that's fine. When you move and you get settled and you get your gauge set up again, you just re-sign up based on your new location. Let us know your old location that you've moved. We will close that down so we at least have some observations from where you were at. And then you can start your observations in your new location. Now, when it comes to being on the 3rd floor of a condo, you might have to see, is there a commons area with the apartment complex or the condo area where they would let you install the rain gauge. We actually have had some people who live in an apartment complex, and the apartment complex has let them install a gauge out in the commons area, and they just get up every morning, go out there and read the rain gauge. And in a couple cases, I've actually heard they've made it sort of a group sharing project where, you know, a couple different residents, they'll take turns going out and taking the measurement. So be creative with the program. Unfortunately, you're just not going to be able to install that gauge on the third floor. It's going to have to be down on the ground in an open area.
Excellent, excellent. Okay, looks like we've got one left in the Q&A, so I'll handle that, then switch to the chat. This is Indiana, so if you have a mixture of rain and snow on the same day, what do you do?
Great question. Yeah, so this is, again, where it gets difficult. There's going to be circumstances that pop up where you might have to ask questions during the program, but when you get a mix of rain and snow, first of all, that's all going to be collected into that 4-inch gauge. When you go and you melt that down at 7 a.m. the next day, you're just going to report whatever liquid is in that, whether or not it's from rain or snow or the combination that goes in the liquid column. Your snowfall then, this is where it's tricky, because let's say you get 3 or 4 inches of snow and then it turns to rain. That rain's going to melt the snow. So we see varying amounts reported in those situations. So again, this is an exception to the rule. If you know the snow has ended and then it's going to start raining, you can go out and take that snowfall measurement before or as it's changing over to rain to get an idea of what's on the snowboard. Then you take your normal snowfall measurement the next morning at 7 a.m. You would still report what's on that snowboard at 7 a.m. So, you know, that snow's probably decreased. Maybe it's down to 0, maybe it's a lot less. But then in your notes section, you would write that you measured the snow before it changed over to the rain and you had X amount of inches. That way we get both. Now, you know, like the one animation said, you may not be home when that happens. Just take your normal measurement at 7 a.m. the next morning, report what's on the snowboard, and then maybe in notes just say there was probably more snow, but it changed over to rain, and we ended up with less snow by the time I observed. I've done that many times myself. Again, it helps folks when they go back and look at your report. Oh, this is why, you know, they're 2 inches less than someone else. You know, they didn't get the observation made at the right time, or it changed over to rain and it melted it. So it just lets us know what's going on.
Okay. Where can I buy the gauge? How long does it take to get?
Okay, so on the CoCoRaHS.org website, on the right-hand side are a couple vendors, and you can just click on them, go to their website, and order from them. Typically, it's, you know, usual shipping. Now, you know, with the Postal Service and the, Parcel Service and FedEx being so busy, I'm not sure how long it's going to take to get a gauge. Hopefully, you know, it won't take more than a week. But I just, right now, it's tough to say. So whatever it's taking to ship these things, you're probably going to have to wait maybe a little bit longer to get those. But I will say there are some imitation gauges out there, especially on Amazon, that say they're CoCoRaHS certified, but they are actually not. So I really recommend you go through one of the 2 reputable vendors that are on the CoCoRaHS website and get your gauge from them.
Okay, next question is, we measure in the summertime directly after a rain event and it's 0.12 of an inch. 7 a.m. the next morning, it's 1/10 of an inch. How do we account for evaporation?
That's a good question. Typically, we usually don't see a lot of evaporation unless that rain fell probably, you know, 8 or 9 or 10 in the morning, and then you had all day, and then you take the reading the next day. So when it comes to rainfall measurements, you can take multiple reports. So you can go out after a rain shower, let's say at 10 in the morning, you look at the gauge and you have 12 hundredths. you can use that measurement then for rainfall. It's just that snowfall where we can't take those multiple measurements or take an early measurement or add the measurements up. So yeah, if you go out and read that rain gauge and you got 0.12 of an inch and you evaporated during the day, you can report that 0.12 for rain in the warm season.
Okay. We've also got a hail pad in the mail. Is there a separate training for that?
Yeah, that's great. Love to hear that. So again, we don't go into that training. It takes extra time, and we don't have a lot of those observers here in Indiana. But there is training on how to use that hail pad on the CoCoRaHS website. It's very easy to do. Just make sure that you stake it down so it doesn't blow away. But that's fantastic. We don't have too many of those observers, so great. Thanks for doing that.
Okay. Alex wants to visit with Beth Hall at the office, but also wants to know if there are any weather camps locally, hoping to attend WKUs in 2021, but wanted to know about any Indiana camps.
Again, with what's going on right now, I think most camps have either been canceled or on hold. There's several TV stations. I would check with those depending on what part of the state you're in. They tend to do some of those, but right now everything I'm hearing is on hold. So just keep an eye on the television websites, and I think a couple Indianapolis stations are doing like some YouTube weekly sort of weather education segments, so you might want to check those out as well.
Okay, that catches us up in the chat. We've had nothing new in the Q&A, so I saved one question for last that doesn't necessarily apply to CoCoRaHS, but is also always a fun question to get. We've got an individual with a bomb cyclone in her forecast. Could you explain what a bomb cyclone is?
Oh, great question. All these questions have been great. This is really good. So a bomb cyclone is a term that's been around, just like the polar vortex, for decades. And it's when a low pressure system develops very rapidly. So the definition is if the pressure drops 24 millibars in 24 hours, then it's considered a bomb cyclone. We call it the kind of the non-technical term. We say it's bombing out. When you get that rapid intensification, the storm just strengthens and gets very intense very quickly. So it's like dropping a bomb. The weather explodes. So that's kind of the terminology that came about probably back in the 1950s or 60s is when it was originally termed. But 24 millibar drop in 24 hours creates a bomb cyclone. So it's just a term given to a strong, deepening low pressure system.
Okay, that catches us up on questions. We do have Andrew White on the attendee list, and I cannot make him a panelist, but I can mute him to see if he might have any comments for the group. And there you are. Nope. Yep.
All right. I just wanted to say hello to everyone. You may have gotten an email from me over the last month or two if you signed up. Just want to thank you all for being on this presentation, and then just kind of introduce myself also as one of the state coordinators for Indiana. I'll be the one that'll be looking over a lot of the data. So if you get an email from me, just wanted to let you know that I'm around, and I'm also with the National Weather Service office in Indianapolis.
Thank you, Andrew.
Andrew does a fantastic job with all of your observations and sort of sorting through the statistics, and he's a large part of why we have so many people on this call today and attending. So thanks, Andrew. And yeah, when you get a message from Andrew, don't be afraid. He won't bite.
Okay, we'll turn it over to Beth for any closing thoughts.
All right. Well, thanks, Sam. I did want to bring up one more topic, because I know it's a fairly common one, and it might have appeared in the chat, but seasonal observers. There are some folks that either just move to a different state for part of the year or know they'll be gone. There's some people that just do not want to deal with the snow. So what advice do you have to give to them, Sam?
Just take the observations when you can. We're not going to close your station unless you've gone probably a year or more. So, we do have some people that they have a gauge in Indiana, they have a gauge in Florida, and they have two separate stations. That's perfectly fine. And yeah, so take your observations, report when you can. We have some people that maybe they haven't taken an observation in a couple months, and suddenly they get 3 or 4 inch rainfall event. That's fine. Go ahead and report. Your station's still there and available. We'll take the data when we can. We obviously want you reporting daily, but we know it's not always feasible or logistic. So if you don't report for a week or two, don't think you can't come back and do this as well. You're always welcome to come back and take your observations. We want people coming back. Your data is very valuable to us. So seasonal, or if you've gone a couple of weeks or a month at a time without taking an observation, don't worry about it. Just go ahead and enter your data when you get back.
All right. 2 other things I wanted to mention is we do have monthly newsletters that go out. We've been doing this for a while now, since about last fall. The general monthly newsletter will come out after midway of the month. So we usually shoot for around the 15th to the 20th of the month. And there we try and put an article, at least one in there, that kind of continues the training or sends out reminders. But if you ever find that, you just can't seem to figure something out, or you have ideas for articles that would be helpful as a refresher, be sure to email me or Andrew or Kyle Brown, Casey Hoover, or other state coordinators. Sam, you can always reach out to him. I also tend to send out an email within the first 10 days of the month to remind folks to go back and check their reports for the previous month, which you can totally do. So there'll be information in there, because maybe you thought you entered something every day, but if you go back to the website and check, you'll see, oh no, I missed a day. And sometimes if you just pull up the map for that day and see everyone else on that day had a 0, you can just sneak a 0 in. I do that. I don't know if it's cheating or not, but that way I have a complete month of reports. And then the last thing I wanted to point out is we are looking at some freezing temperatures tomorrow night. And while I don't quite know what the precipitation situation is, I thought I would just toss out a reminder for any of you that might have put your rain gauge out and you have the inner tube and the funnel and it is sparkling brand new. Maybe remove that inner tube and the funnel, because you would hate to have that crack and break and you haven't even really started in the program. Or maybe you've been in the program for a while, but hopefully once we get past this Friday, you can go back and put the funnel back in. Like I said, I don't know, maybe Sam can say if we're expecting precip, but such an unfortunate situation when you realize that inner tube is cracked on you.
That is a great point. And yes, I believe tonight and Friday is going to be just miserably cold and rainy and not fun. So definitely take that out. Just, let the precipitation catch in the big outer tube and then bring it inside and measure it like we talked about. That's perfectly fine. That outer tube can measure rain as well as snow.
So that's all I have. Like I said, so I'll be posting the merging of this training session and then the one we have at 6, because like we said, the content will be the same, but we want to be sure we can capture all the questions in one video. And then if you ever want to see the informational video, and welcome everyone to the CoCoRaHS family. We're so excited to have you, and we love hearing from you, and any suggestions, feedback, please send them our way. So with that, I'll hand it back to Hans and see if we're ready to conclude.
We are ready to conclude. Bill Carter has had his hand raised for a very long time. His arm must be extremely tired. I'm going to unmute him just briefly and see if he has any question. Bill, you should be unmuted. Okay. Well, feel free, if anyone has any additional questions, to reach out to any of the 3 of us. Okay, Bill says he's good. Okay. You have Sam's information on the screen. Beth and I are both publicly available at many different sources online if you'd like to reach out to either of us. Thank you all for attending today. We have one question at the moment, so anyone feel free to enter more into the chat or the Q&A boxes. The question is, how can participation in this program help a participant in the future? Very existential for you.
Help the participant in the future.
Yes.
Maybe a sense of purpose, knowing that your observations are helping scientists, helping future research, helping us track precipitation trends across Indiana. We're definitely using that data right now. So maybe a sense of accomplishment by helping with that. Certainly, if you're a younger person, you could do this for the rest of your life. You could do this, become one of the longest observers in the history of CoCoRaHS. How about that for a goal? You kind of make out of the program what you want to make out of it for yourself. But I can tell you from our standpoint, the data, the observations that are collected are just invaluable. I can remember back into the 1990s where we'd have a rain or a snow event, and we didn't know how much rain or snow was falling out there. We really had to start making phone calls. And with CoCoRaHS, it's just been awesome to get data from pretty much anywhere in the state, and we just want to fill those gaps in and add more observers and get more observations.
Okay. Let's see. I don't see any other written questions. We've got one hand up. So Brittany, I am going to unmute you here so you can ask your question. Go ahead. Yes, we hear you, Brittany. Okay.
Was there a question there? I didn't hear it.
And now we've got a thank you to the panelists in the chat, but that appears to be all the questions. Oh, no, we've got another one.
All right.
Does the gauge have to be attached to a standalone post, or could it be extended above a fence or some other object?
That's a great question. So ideally, it's not recommended to be attached above a fence because you can get some wind patterns that might affect it. Now, with that being said, I just moved from a house where I had my gauge since 2008, and I did have one on my fence post. And honestly, my observations compared to other observations and another gauge that I had were very, very similar. So if that works for you, as long as you get it, like in the picture here with that gauge, you get it as close to the top of the post so you're not getting splattering or you're not getting excess rain somehow getting into that gauge, I think you're going to be fine. And I'd rather have you do that than, put a post out in your yard when you really don't need to. So yeah, if you've got a wooden fence and you can get it as high above the as possible, that'll be fine. We've seen it done before.
Okay, we've got, how do you measure sleet?
That is a great question. Very carefully. It's a treacherous thing to measure. Bad dad jokes, sorry. So yeah, sleet will generally melt on the snowboard, but if it freezes, then it becomes a little bit more difficult. There's some training on the CoCoRaHS website, and honestly, I think rather than me try to explain it here, it would be best if you go and view those videos. But again, whatever falls inside the gauge, you're just going to melt that down and get the liquid equivalent of it, and you report that in your rain and or snow box on the on the form. So that's what you're going to do in the gauge. It just becomes more tricky when it's on your board, depending on if it melts or if it actually freezes. So freezing rain, that's going to lead to ice accumulation. You may have to chip away at the ice on your board and measure the depth of that ice. But for that, for now, we'll refer you to the training on the CoCoRaHS website on how to take those measurements, as that's going to get a little long-winded, more than I already am at the moment.
Okay, we've got a hand up, so we're gonna try to go to Kim here and unmute. Kim, would you like to ask your question?
Yeah, I had a question on what happens if there's a significant rain or snowfall event during the time I'm supposed to be reading it? Do I go out there and I pull the gauge out, I'm going to miss something, and it's going to lower the reading for the following day?
Yeah, excellent question. So there's a couple things you can do. If you have a second gauge, you can quickly go out, put the second gauge in, take the first gauge off, and get back inside. Number one thing here is we want you to stay safe. So if it's a heavy snow event or if it's raining really hard, we don't want you to quickly go out there and then slip and fall and have something happen. So it's probably best if you can wait until the rain has let up a little bit or ended. Maybe you can look at the radar. You can again adjust that observation time, but there's some days where maybe it's just going to rain for 2 or 3 hours at a time, and yeah, that's going to be a problem, and you just kind of have to do your best you can. So maybe just wait for that precipitation to lighten up a little bit. Go out, bring the gauge in, take your reading, and then take it back out, and hopefully what you miss will just be a very small period of time. Again, there's some video training on that on the website, but you just kind of have to make a judgment call.
Okay, just to get this out of the way, you have Sam. You have supporters that miss you from the IWX area, and want to congratulate you on your new role in Indianapolis.
Well, thank you. You're keeping me in the dark there, huh?
Kim still has his hand up, so I'll give him an opportunity to take it down if the question was answered, leave it up if it is not, and ask this question. Beth or Sam, does anyone happen to know what the highest annual rainfall amount was for 2019 in Indiana?
I'm going to leave that up to Beth or even Andrew.
Yeah, I was quickly trying to look it up online what the answer was. It's a tricky one to answer because when you say in Indiana, really there are hundreds of stations that I could look at to try and figure out what was the highest one for all those stations. When we try and report what the state average rainfall was, I might be able to get it, but I have a feeling that you were asking more, what a single one-day observation, what was that record, if you will, in 2019, and I'd have to go through the numbers, but I don't have it at the top of my head. Maybe Andrew has that memorized?
Yeah, so I just quickly looked it up. So the station over the course of the whole year was down in Orange County near Paoli. So Indiana Orange 13 was the station number. And last year they had 75.54 inches of rain.
That is pretty impressive. And again, that's part of a research project that all of us are working on and using CoCoRaHS data to help, but we're seeing an increase in precipitation in the southern third of the state. And so CoCoRaHS is helping us track those. So that's actually a really good question. So thanks for putting us on the spot there.
I'm surprised we got such a quick answer. That's great. Okay, we've got one question that's kind of a multi-parter here. How high above the ground or above the post does the open end need to be, And should we use a level to make sure all 4 inches of the circle open horizontally or level horizontally?
Yeah, so yeah, if you can use a level, you can probably eyeball it to make sure it's close. But if you have a level, go ahead and check it. What I will try and show you here using my gauge is you see on the gauge here, there's these little plastic pieces, and those slide into the post here on your wooden 2x2 or 2x4, whatever you have. But you're going to have to screw those into the post. So you can only get that so high on the post. And then when you slide your gauge in, it's going to stick probably about 3 inches or so above the post. So you want to get it as high as you can to attach your frame on there, and then your gauge will just slide right in there. So you're going to be a little bit limited there. You see the picture with Nolan, that's about as high as you're probably going to be able to get it above the post.
Sam, is there like a minimum height? So if you were to do a post in the middle of the yard, does it need to be at least a foot above the ground?
Yeah, I think the recommendation is at least 3 feet, and that's what my little thing here is, just on a little flat piece, and it's right about 3.5 feet, I think. And so this is just one we made to take around to do talks and such. So yeah, that's kind of probably your minimum height, because again, you don't want it so close to the ground that animals or things like that can get into it and disturb it. And you also don't want rain or snow from the ground being lifted up into it. So I would say, to be safe, at least 3 feet off the ground, and ideally somewhere around between 4 and 5 feet, just somewhere that you're keeping it away from those false contaminations that can occur. Good question.
Okay. I believe that catches us up on questions, and I don't see any hands raised. And it is about 20 after the hour, so perhaps we've taken enough time. Turn it over to Beth and Sam for closing thoughts.
All right, well, I'll just say it's great to have as many of you guys on as we had today, and even earlier today, just seeing the enthusiasm to learn more about this program and sign up and get involved. I'm excited to see the additional dots on the map and in the future. We have been doing a monthly newsletter that comes out around the 20th of the month, and there's articles in there, and we try to put in reminder things. So if you saw this training and then later you're like, oh, I don't remember what it was, certainly reach out to me or Andrew or any of the other coordinators or Sam, Hans, because maybe you're not the only one that's asking that question, and we can get that article in there. I also tend to send out an email in the early part of the month to remind folks to just look over their data for the previous month, and there's instructions on how to do that. And then I think the final thing was just a reminder. I didn't think I'd have to be saying this in May, but we do have a very cold system coming through tomorrow night. So for those of you that have your rain gauge out and the inner tube and funnel in there, don't know if there's going to be enough precipitation, but even just a little bit of precipitation, if it freezes in that inner tube, I know I have lost, embarrassingly, 2 inner tubes over my career with CoCoRaHS because I forgot that it was going to freeze that night. So I would encourage folks to try and remember to take out your inner tube and funnel, at least for the Friday night, Saturday morning run, so you don't lose your gauge and then you can't take observations anymore. With that, I'll hand it over to Sam, see if he has any closing comments.
I think I've talked enough, but I just want to thank everybody for being on. I agree with Beth. This has been great. This is the first time we've done a virtual webinar, and I think we're going to have more of these, and maybe we can cover some of those more advanced talks. And thanks to Andrew for being on both of these and for being a great coordinator and handling all the quality controlling of the data, and Hans for hosting, and Beth for your leadership in all of this. It's been fantastic, and it's great to see CoCoRaHS on the upswing again in Indiana. So with that, that's all I've got. Hans, back to you, I guess.
I just stop recording, and just like that.